and do a quick review. Okay. So, which is good for you guys. Formula, rate times time equals distance. We know that. So, our chart, whoa, what happened there? So, our chart is going to have a larger rate column times time equals distance. Again, I always include the equal signs. That's a nice little thing. Make your top column or top row with the wind or current. Make the bottom against the wind or against the current. Okay, the rate column contains the aspect of the wind or current. Make X the object of the problem. The boat, the plane, the train, the car, the bike, whatever is going with the current or wind or against the current or wind. Make Y the wind or current. With the wind or current, you got to add. So it's X plus Y. Okay. You add the wind to the boat or train or plane or bike. Against, you subtract. So you subtract the wind or current from the boat or train or plane or whatever. All right, the two equations come from the two rows. There's one equation. There would be the other equation when the chart's completely filled out. That's easy. No total, no comparison. Don't have to worry about that. Solve the system by substitution or elimination. All right, so let's do a problem. Let's see if we can put that into practice. Here we go. In 3 hours, Tim rafts 15 miles downstream. I think that's 2 words, but oh well. It takes him 5 hours to paddle back up the river to their camp. What is the raft speed in still water, and what is the rate of the current? We're asking 2 questions. What is the raft speed in still water, and what is the rate of the currents? Okay. You always want to start these with NTV. So you're going to write your chart. It's always this way, it's always this way, it's always this way. The formula rate times time equals distance. You're going to put a bigger block for the rate. Again, keep the equal signs. They're going to help you. Make sure you label the rows with the current, with the wind, against the current, against the wind. Okay, so what are we going to make the X? You know what? Hold on a second. Think about it. So I want you to give me an actual answer. I don't want you to tell me the principle. I want you to tell me what is X going to be. All right? So think about it. Look at the problem. All right. If you're there, backpacks, by the way, need to go underneath your desks so we don't kill people in a fire drill. And on 3, tell me what X is. 1, 2, 3. Would be the raft speed, right? You could say the raft, but raft speed is a little bit more descriptive. And Y is going to, don't say it yet. So what is Y going to be? Look at our specific problem. And on 3, tell me what Y is. 1, 2, 3. Y is the currents, right? You could say the stream rates, but it's the current, right? You can say the current rate or the current speed if you want. Okay, on this kind of problem, I would always fill in the rate column first because it does always involve the variables. So go ahead and fill in your rate column, and let me give you time. I'm going to pause the video. All right, if you understand, you're done. If you don't understand, you're not done. How many are done? Okay. All right, don't make this hard. Your rate column will always look like that if your top row is with wind or current and the bottom is against. And you make X the object and you make the Y the wind or the current. Your chart will always look like that. Always, 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 always. So what do we have here? And again, if you're smart, you'll use your parentheses. With the current is add, against is subtract. We need our raft speed. We got to add the current going with the current, and we got to subtract the current going against the current, right? That's every time in this kind of problem. So that's simple, right? Once you do a few, you get it down, so I'll always see students do that, right? because you got to remember it. Unfortunately, some don't remember. Okay, we have 4 blocks left in our chart, correct? Fill in those blocks. See if you can fill in the 4 blocks of the chart. 2 down, 4 to go. I'm going to pause the video, see if you can fill those in. Okay, what do you want the time to be with the current? Say it if you know it. 3, right? Time against the current. Beautiful. All right, 4 down, 2 to go. 2 blocks left. All right, on 3, give me your distance with the current. All right, on 3, everybody now participate. Here we go. 1, 2, 3.
3x plus 3y.
Oh, that's why I said I should have told you to do it in pencil. Da, 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 da. Read this. And specifically, read that. Anybody want to change their answer? Anybody converting? Conversion, I got 1 conversion, 2 conversions. You know what you're converting to? Let me give everybody a minute here. Remember, these problems are different. Why did I separate them, though the book doesn't? Because they're done differently, okay? And I want you to be able to separate them in your mind. So, here we go. On 3 now, let's try again the distance with the current. Here we go. 1, 2, 3. 15. The distance is 15 miles. What is the distance against the current?
15.
In this problem, they went back to the same spot. They don't always. Sometimes they'll tell you on the way back, they paddled to within 3 miles of the spot where they started. And you have to take that into consideration. But in this problem, they went back to where they started. So it was 15 miles down, it's 15 miles back. Okay? You got to take that into account. Now we got a shot. Cool. Now we need 2 equations. Can somebody raise their hand and give me one of the 2 equations? Anybody raise their hand? You have notes in front of you. You can look. I put in a nice gray box words to help you to remember what we did. Kirsten, give me the first equation.
Parentheses x plus y parentheses times 3 equals 15.
That would be the first equation, because you know what? The rate times the time equals the distance. Some of you guys distribute better when the 3 is in the front than in the back, right? Could you put it in the front? What property allows you to put it in the front? Commutative property, right? So again, if you distribute better from the front, switch the order there. Again, a lot of you distribute better that way. So the second equation, here I'll do it in blue, is the second row. Again, this is why students actually like these better once they understand the wind current thing, because the equations are easier. So again, instead of putting it in the back, I'll put the 5 in the front, because most of you distribute better that way. So we have 3 times the quantity x plus y equals 15, and 5 times the quantity x minus y equals 15. There are 2 equations. Now in this kind of a situation, we have to decide if we're going to solve by substitution or elimination. Quite honestly, we need to distribute here to get this equation in a better form. 3 times x is 3x. 3 times y is 3y. And that equals 15. A second equation when we distribute the 5 is 5x minus 5y equals 15. If we use elimination, or if we use substitution, are we going to have fractions to deal with? So you can't forget the 2 methods. Substitution, solve one of the equations for one of the variables. If you solve the top, the red equation for the x, don't you get fractions? If you solve the top for the y, don't you get fractions? If you, actually, we could do the top. This one you could actually solve by substitution. Here, okay, so watch. Here's my thinking. If I solve the top for x, I'll end up with a 3y or a negative 3y divided by 3. Does 3 divide by 3? Does 15 divide by 3? Ah, so actually I won't have fractions. So I could choose either method on this one. What do you guys want to do, substitution or elimination? You want to do elimination?
Yes.
If I use elimination, what do I have to do? I'll have to multiply the top equation by 5 and the bottom equation by 3. Because again, you got to, and that one you'd be going for the y's, correct? Because they're already plus, one's positive, one's negative. So either way, you can solve the top or the bottom one for either x or y. There won't be any fractions. Or you can go, let's go elimination, because most of these are elimination. So we're going to multiply the top by 5 and the bottom by 3. All right, here comes the new red. Let's do it over here. So let's see, who wants to belt out the new red for me? Go ahead, Raquel. New red is? And hopefully you agree, right? She distributed that 5 to everything. Okay, so that makes me have to pause. 15x plus 15y equals 75. Well, everybody watch for a moment. I want to keep you from making a mistake. Don't do this in your notes, but look here and look here. In the left-hand side, this 3 was only distributed to the parentheses, right? In the second, the 5, the whole equation is in a bracket, and that's why the 5 gets multiplied times the 15 on the other side. Don't get those confused, right? The difference is what's being distributed to where. You guys got that? Because again, students all of a sudden start. Here's what I see. Students all of a sudden on this front one want to make that a 45. Well, that's not a 45, right? The 3 isn't distributed to the 15, only to the parentheses, right? So don't make that. Don't get confused now because we're now doing this type of stuff with elimination. That's what I'm trying to get at. Okay. Let's do our new green. Who's going to give me the new green? Kaylin, give me the new green.
15x minus 15y equals 45.
Okay, I lost part of my... So I heard 15x minus 15y equals 45, and that's correct. And this is an equal here. And that should have been the new blue, but who cares? Remember elimination, you're out to get one of the variables to be equal and opposite. Our y's are equal and opposite. 15x and 15x is 30x. 15y minus 15y is 0. Bingo, that's what we wanted. 75 and 45 is 120. We can do our shortcut and divide the left by 30, right? And we now have x equals 4, not 40. 120 divided by 30, you punch out on your calculator, is 4. Now, I did NTV. Some of you won't do NTV. So I hope you'll know what in the world X is. I know what X is because my NTV says X is the raft speed. Oh, 4 miles per hour for the raft. I know that because I named the variable. Now, we're not done because it also asks you. Now, sometimes you'll be done. Maybe the question will only ask for the raft speed, the bike speed, the plane speed. But this asks for both, so we got to do the current. So I got to find y. And remember now, I'll put 4 in to either any of the equations. So in any form, I'm looking for y. I'm going to take this 3x 3 times, that should be red. Keep getting my colors off. I'm going to take this red one, 3 times x, I'll sub in a minute, plus 3y equals 15. Right? Take my 4 and stick it in. Add a negative 12 to both sides, right? 3 times 4 is 12. Add a negative 12. You get 3y equals 3. Divide both sides by 3. And we got y equals 1. Again, what is y? I look up at my chart. Y is the current. So 1 mile per hour currents. I've answered the question. The MAMS likes the answer. Hey, if I would have gotten the current going 100 miles an hour, like whenever is the wind or current 100 miles an hour? Okay, that doesn't make any sense. So you got to think about it. If the guy's biking and you got the guy going 1,000 miles an hour, you got to think, okay, how is this even possible? The guy's biking and he's going like 0.5 miles an hour, you got to say to yourself, okay, who is this? Like Grandma Moses on the bike, 0.5 miles an hour. So again, think a little bit about your answer. We're going to try in the most part to give you round number answers. Not always, but most of the time. All right, let's do one more now, see if we can get it done. So I'm going to pause the video in a moment. I want you to just set it up. I want you to set it up and fill in the rate column and stop. Set it up, fill in the rate column, and stop. A lot of math is paying attention to detail. Somebody said the devil's in the details. I don't even know what that means, except that the concept is the key is the details. The key is the little details. I coach basketball. Take 2 guys with the exact same ability, exact same. One guy knows the details and the other guy doesn't. The guy that knows the details will just completely destroy the other guy. The key is in the details. So I hope you've got the details. So did you end TV? I know not everybody did because I'm looking at one that didn't. Because again, when you're done, you got to figure out what X is and you got to figure out what Y is. I hope you end TV. Did you put a parenthesis around the X plus Y and the X minus Y? That's going to help to key your member to distribute. Because without it, you probably won't distribute and you'll probably get the problem wrong. So that's a little thing. Did you write with wind and against wind? Did you name your rows? All right. Any questions on that part? All right, fill in the chart. I'm going to pause the video. Do the rest of the chat. All right, so is that what your chart looks like? Oh, let me unfreeze it. 2 and 3 and 960, 960. Okay, again, this is a second example where the distances are the same. The distances are not always the same. So be aware of that. Just be ready for that. Don't get automatic in, oh, it's the same. A good amount of problems it is, but others it's not. A distance, they won't go all the way on the way back. Something like that. And they'll tell you, and you can figure it out. But 960, not the other. Okay, write your 2 equations. And then you got to decide on elimination or substitution. I'm going to go blue and black. And I'm going to put my distributed number in the front. And I'm actually not going to go over top each other. I'm going to go left and right so that when we modify them, you don't have to. It's just going to save us some space. Right? The equations come from the rows, right? It makes it a whole lot easier. You don't have to think the type of equation. It's just the rows. At this point, you do have to say, do I want to go for substitution or elimination? So again, I did the 2 times the x plus y equals 960, and I did the 3 times the x minus y equals 960. I'm thinking we're going for elimination, correct? Let's go ahead and distribute and see where we end up. You can go ahead and do it yourself. I'll do it as well, and you can look and see if it's the same. So do it off your paper, and then look up and see if you got the same thing. It's just 2x plus 2y equals 960. 3x minus 3y equals 960. Agreed? So elimination method, do we want to eliminate the x's or the y's? One's a little bit easier, the y's, because one's already positive and one's negative. This way we can do the multipliers both being positive. All right, so now we got to multiply the blue one times something and the green one times something. So somebody raise your hand. Tell me what to multiply the blue one by. Adam?
Negative,
2, not the blue one. Not 2. Lauren?
3.
3. So the blue one by 3. The black one by, Adam? 2. Right. So the blue one's by 3. The black one by 2. That's going to get our y's to be positive 6 and negative 6, right? Now we're ready to multiply them and put the 2 together. So get your new blue. Get your new black. Again, go ahead, you do it on your paper. I'll be doing it up here at the same time. You can look to see that you're doing it correctly. Might need your calculator. I'm grabbing mine. Although I'm almost there. That is a y.
No, on the top.
That is 6x plus 6y.
Okay.
Okay, so hopefully you did end up with 6x plus 6y equals 2880. And then 6x minus 6y equals 1920. Add your x's up, 12x. Your y's add up to 0, right? What you wanted, right? And then hopefully you still got your 1920 in your calculator. You can add the 2880 to it. And I got 4,800. Somebody tell me what to do next. Come on. Ashton, what do I do next?
divide both sides by 12.
Great. So I'm going to divide both sides by 12. So hopefully your calculator already has the 4,800 in it, right? Divide it by 12. And I now know that x equals... Sam, what do you got for an answer?
4,000.
4,000? All right. You'll have to ask the ma'ams on that one. Are we in a plane?
Yes.
Okay, but that would be like, what's the speed of sound? Anybody know? Yeah, like 600 and something miles an hour. So 4,000 is like Mach, I don't know what. So, Adam, what do you got? 400. So you're off a decimal point there, Sam. All right, so again, what is 400 though? Well, I NTV'd, and it's the plane speed. And we're doing miles, and we're doing hours, so this is 400 miles per hour plane, right? Agreed? All right. Finish it out. Figure out the speed of the wind. Again, I'll be doing it while you're doing it. You may not choose the exact same equation as me. Go ahead and figure out the wind speed. Must have been a hurricane. What wind speed gets classified as a hurricane? I think it's 75, I think. Does that make sense? Would it have been a hurricane? Make sense to anybody? Why does that make sense? Huh? Because it's a hurricane? How often are there hurricanes?
For word problems all the time.
So, I mean, our work's good. So why did they pick a hurricane? Or did they pick a hurricane? What's that, Connor? Oh, are the winds on the upper level like sometimes hurricane force? Yeah. Oh yeah. Get in the jet stream. It's not a hurricane because the winds are aloft, right? You can get some pretty nasty winds when you're at altitude, and that's the situation they're at altitude. So 400 miles per hour plane, 80 miles per hour wind. The MAMS likes the answer. I'm happy with that. And away we go. All right, so tonight, work on those problems, 21, 28, 32. You B minus and above people do 30. Just so you know, oh, I gotta stop the video. Stop the press it.